This is the second lecture on process data representation and analysis. And this one we are going to talk about plotting data on linear, semilog, and log plots. And specifically we're going to talk about how to do this in Excel. So I am sure that this is a review for many of you, but let's go through it to make sure we're all on the same page. So here's a set of data. We've got X and Y data. Okay, so this data was measured concentration of ethanol in water in equilibrium with a gas stream containing CO2 and ethanol. So we have X in the liquid and Y in the vapor. Okay, so let's use Excel to determine the best model for this data. All right, first thing you do is you put it in Excel, and then you go to Insert tab, and you click on the scatter plot. Okay. And then if you choose this option, it scatters only with markers. That's the best. Okay, so now you've got the scatter plot. So the next thing you're going to do is go to the Select Data tab. Okay, and when the dialog box opens here, you are going to choose Add and hit OK. All right, now you can type in a name, equilibrium ethanol equilibrium data. Then you're going to select the x-axis, select these values here, and then you're going to select the y values here, click OK, and then now we have our data in there. Okay, click OK. There's our data. All right, we can add, if we go up here to layout, it'll give you the layout, and you can put in axis and all that. Okay, so now I'm asking you in this, we can see visually that it's not a straight line, but Excel will tell us exactly. So what we do is we just put your cursor on one of the data points. Just click it on the data point, and it'll X all these datas. Okay, and then you go down to, if you right click, okay, then you get, you can say choose a trend line. Okay, so right now we're looking at, Excel will by default put a linear line. It's going to fit this linear regression. It's fitting the best straight line to that data. Okay, so you might be happy with that because it has an R-squared of 0.95, but in fact you can see clearly that the line does not fit the data. Okay, so let's try. We've selected here display equation and display the R-squared. So, but now let's try another type of line that will be a better fit. Okay, so here we go. This is a second order polynomial, and this one fits very nicely. Okay, so that's plotting data, and now let's talk about semilog and log plots. So if you have a semilog plot, okay, that means that one of the axes is a log axis and the other axis is a linear axis. Okay, and the equation that fits a semilog plot is this one. Okay, all right, it is log in the y and linear in the x. X is t and the y here is f. Okay, so how do we get this equation? We are going to take the natural log of both sides. Okay, if you take the natural log of both sides, you get an equation like this one. I encourage you to practice that. All right, now we're going to just plug in these data. Okay, in the slope of that equation is b. We use b as the slope and a as the intercept. Okay, so if we calculate the slope, it's going to be the natural log of f2 over f1 divided by t2 minus t1. Get the slope. Now we're just going to plug in, we've got the slope now, we'll put in this slope. It's and we were going to calculate the intercept. Okay, so we will now put e to this bt to get our a. Okay, and now we can get our full equation for the line. Okay, the log plot, we have both the log axis on the y and on the x. Okay, so the log equation is a power, also known as a power equation. Okay, so this time we have, to calculate our slope, we have the natural log of the y2 over y1 and the natural log of x2 over x1. Okay, and so now we calculate our slope, plug it back in, and our equation will fit this. And we can plot these in Excel. All right, so this is a semilog plot, but we have it. This is a semilog plot, but in fact, we have linear axis. This is a linear axis, and this is a linear axis. Okay, if we make one of the axes, the y-axis, as a log scale, okay, then now note that for the above plot, if you calculate the natural log of f and plot against t, you can plot a linear equation. So you actually, in your data, you take the natural log of the data. If you put on the axis a log axis, then you actually can just plot the data. But note that in order to get the correct equation, you want to fit an exponential equation when you choose the trend line. Okay, for the log plot, the log plot has a log axis on both. And again, if you can plot it on a linear axis, as we did in this one here, if you take the natural log of f, of the y, and plot it against the natural log of t. So again, you calculate the natural log in the Excel data sheet and then plot it on a linear axis. You can plot the data as is if you put it on a log, the two axes are log axis. In this case, to get the line, you choose a power series. Okay, so I want you to do this exercise, and this will be in the video lectures 2.2. Okay, so this will be a quiz in the video lecture. So I want you to first plot the data in Excel, fit an exponential curve to the data, and report what is the equation. Okay, you can just type that in. Then you should estimate the equation for the data using the data of the cell concentration between time 3 and 4 hours. Okay, assuming a straight line connects the two data points. So now I want you to do a straight line equation between 3 hours and 4 hours using these two values of cell concentration. And the answer to that is the equation that you calculate. And now I want you to explain, for question number 3, explain the discrepancy between the equation of the data determined from Excel and the equation you determined in number 2 above.